In this lesson, we'll talk about data type conversions. Sometimes you're going to need to convert one data type into another data type. I'm going to show some examples in this lesson, and as you build more complex applications, especially applications that receive input from user interface controls like server controls on our web form pages, it'll become apparent why you need to do this. All right, so just stick with me for a moment here, and we'll work our way through this. Now you'll notice that I've already got this lesson set up. I've already created a new project called CS-ASP_008 that corresponds with this, I guess, lesson identifier, lesson number. I'm roughly using that to keep everything kind of ordered correctly. And I'm going to give it to you as a starting point. You can open it up and you can use that as a starting point. You don't have to type in or create all the code yourself. It's in a before folder. There will also be an after folder, so when I stop recording this video, I'll stick the finished product in, but you can just use this to get started and follow along and kind of get to the starting point where I am. Or feel free to build it yourself, pause the video, and meet me here at the OK button _click event. All right? So let's start off by talking about variables again. And once a variable is declared as a certain data type, it cannot hold values of another type. All right. So, for example, the easiest way to demonstrate this is to create a new variable called I of type int, and then I try to set int equal to the string hello world. And notice immediately I get a red squiggly line. The red squiggly line means that you have a compilation error. The green squiggly line, remember, that was just a warning to say, hey, you never used this variable. You created it, you declared it, but you never used it. This says it ain't going to compile. And why not? It's because, and hover over the red squiggly line, look at the error message of that last line, cannot implicitly convert type string to int. So as you can see, Visual Studio and actually the compiler will try to implicitly convert a type, in this case hello world, to an integer when it can. Now, when it can't, then you must explicitly take control and perform the conversion yourself. Okay? Now, in this particular case, even if you tried to take control and do the conversion yourself, there's no way in the world this will ever work, because hello world doesn't translate into a numerical value. All right, it's just letters, alphabetical letters. But if this was the string 3, for example, here, let's go here, 3, well, it's possible in that case that we could convert that string 3 into an integer 3. Okay, but you would have to, as the developer, take control of that process, and we'll talk about this a little bit more in just a moment. Now, when you see the red squiggly line, that means compilation error. That means you have to fix the code before it can even be compiled into a .NET assembly. Easy enough, right? So let's go ahead and just comment this out. But I think the interesting thing was that the compiler, actually Visual Studio, working on behalf of the compiler, showed you that it attempted to do an implicit conversion, but it couldn't. All right. So there's two types of conversions. There's implicit conversions and explicit conversions. And implicit conversion is like what we call an upcast. So, for example, I have two bowls here, and this bowl has a bunch of stuff in it. And this is a smaller data type, and this is a larger data type. This is like the int data type, and this is like the long data type. And so I can take a value that's in the int variable, this blue bowl, and I can dump it into the other variable that's a long, that's an upcast, because it can hold larger values. But what happens when we try to take the value of the yellow bowl and pour it into the blue bowl? All right, it can't hold it. And so we get an exception and an implicit an implicit conversion can't happen. So let me show you this in code, that same little illustration. So let's start with int I equals 2,000 million billion, okay? And then we're going to go long j equals I. And this will work because we are upcasting from a smaller bowl into a larger bowl, from a smaller bucket into a larger bucket. But the reverse will not be true. So we have long I equals 2,000 million billion. And then int j equals I. And we'll see that we get a little red squiggly line under the I, and it says cannot implicitly convert long into int. However, there's a ray of hope at the end of that error message. It says an explicit conversion exists. Are you missing a cast? All right, so you can, if you can't implicitly do the conversion like it was accomplished here by an upcast, you can explicitly perform a conversion by casting. And casting has a simple syntax. You use an open and close parentheses, and then you put the data type in that you want to cast to. So in this case, we want to cast this I, which is a long, into an integer type so that we can assign it to our new integer variable j. Okay, so there are ramifications here. We're taking matters in our own hands. We're saying that if anything happens, we'll take the blame for it, okay? We understand that the .NET compiler has thrown up its hands and says, I can't do this for you. You have to decide if you want to try and override this, the data types. And so in this case, we're essentially taking control and overriding the default behavior, which is to not allow a larger type, again, the yellow bowl, to fit into the blue bowl, all right? And so this is called a downcast. Whenever you're going from a larger bowl, a larger data type, into a smaller bowl, a smaller data type. But we are able to accomplish that with a cast. So again, a cast is a way of explicitly informing the compiler that you intend to make the conversion and that you're aware that an exception might happen or that data loss might occur. All right, so let's talk about data loss for just a moment. For example, let's do an explicit conversion between a double value into an integer. So we'll do this. Double k equals 2.5. All right, good so far. Int j equals k. So we'll attempt to do the implicit. It won't do an implicit for us. It'll say you're going to have to do a cast. All right, well, we know how to do a cast now. We're going to cast that double k to an integer and assign it to the new integer variable j. All right, now what we'd like to do is print this to our result label. So I'm going to have to do another cast potentially. Okay, so let's take a look at result label.text. And this property, as you can see off to the right hand side, there's that little window that pops up. It says that label.text is a string data type. So that .text property gets and sets strings only. Wait, can't we put numbers in? Yes, you can put a number in a text box, but it will be retrieved back to you as a string value of that number. Just like we saw the number 3 in as a literal string, we could convert it because we happen to know that that is convertible into a number, but it's still, a literal string at the end of the day. So now we're going to try and print j, and what happens? Well, we hover over and say error cannot implicitly convert type int to type string. So it can't convert the j into a string value so that we can show it in our text property. So what are we to do? Well, we know how to fix this, right? Let me actually just comment this out. And we'll do the same thing again. .text equals j, but we'll cast it to string. That'll work, right? uh-oh, what could possibly be the problem? Cannot convert type into string. Wait, so casting is one way to do an explicit conversion. However, it doesn't always work. It usually only works when the types are similar, like numbers to numbers and things of that nature. But going from a string to a number, it just or actually a number to a string, either way, you're kind of you have a chasm there that you have to cross. And so, fortunately, there are helper methods that are available on most data types. For example, the integer data type and all the numerical data types for that matter have a toString method that we can use. So the J says, oh, don't worry about it. I know how to convert myself into a string. I'll just call my toString method, and then it can be assigned to the label. Now, let's go ahead and run the application because we want to see what the value of K was. Remember, we said K is 2.5, and then we downcasted to an integer, and so now we click the go button, and no longer is the value 2.5. The 0.5 got truncated. It got yanked off of the double that we originally had, and that is essentially the problem with casting, is that you're taking matters in your own hands, and it's possible that data loss will occur. In this case, whenever you have any kind of fractional value and you try to cast it to a whole number, you're going to lose everything after the decimal point. It doesn't round up. It always just takes the value, in this case, the whole number side of the equation, and it just eliminates, it just forgets about everything after the decimal point. So even if the value was 2.999999999, it would still forget about all the dot and the 9, and it's still 2. All right. Now, all hope is not lost. If you need some functionality that deals with controlling with the rounding, you can use something called math.round. We're not going to talk about it until probably much later in the series, but I just wanted to point out that you still can take control of that. You just have to go a different route. All right, you can't rely on casting to handle that situation for you. All right, let's go ahead and shut that down. All right, moving on. So let's do one more example. This time, as you can see, we have an input text box. And what I want to do is I want to allow the user to type in a number. Again, we know it's going to come in as a string because the text property of that text box is going to be of type string. And then I want to add a value to it. Now, an arithmetic operation can only be done on another numerical value, not a string value. So we're going to need to convert that string we get in that text box to a numeric value. We're going to perform the addition, and then we're going to need to convert that result back to a string so that we can display it in the result label. So how will we go about doing that? Well, let me comment everything we have up to this point out. And here we go. So string I equals input text box dot text. So far, so good. So we're going to grab the value from the text box. And now we want to turn that I into an integer. So we're going to create a new variable called j that'll hold the integer version. And so when I attempt to do this, I'm going to get a red squiggly line under I because I cannot implicitly convert the type string, the letter I, to an integer, the integer value of j. All right. So what can I do about this? I can attempt to do something like this, int, do a cast, but again, that's just not going to work. Casting doesn't work between categories of types. Alphanumerics and numeric values, you can't do a cast like that. Fortunately, there's a helper method on the integer, so you can go just use the data type itself, so int.parse, and int.parse, and actually all of the numeric data types have this parse method, this parse helper method. And what it will do is it'll take a string value, and if it can, it will convert it into in this case an integer because we got int.parse, all right? As opposed to a double.parse or a long.parse or whatever the case might be. All right, so now we can create k and go j plus 1. We can perform addition because 1 and j are both numerics, and we can, after we have the result, we can put it in another new variable of type integer. So far so good. And now we want to print that to screen equals k. And here again, we're going to have to use the lesson from the previous example. Fortunately, integer has a toString helper method, like so, and we can convert that integer to a string and display it in the result label. So let's see it working. And we'll type in like the number 5 and click the go button, and it did the conversion, added 1, did the conversion, printed it back out in our label. Awesome. Now you might be asking yourself, or try to ask me through the computer, what if somebody types in the word Bob? Well, let's see what happens. I'm going to click the go button, and wait, what? Huh? There was a format exception was unhandled. Additional information, input string was not in the correct format. All right, so the int.parse, oh, I see. Int.parse can only parse out a string that is essentially a number. But when I gave it the word Bob, it didn't know what to do with it. So it created a runtime error. Now, there's a difference. When we see the red squiggly line, that's a compile time error. That means our code won't compile, that type of error. This type of error is a little more insidious because it can't be caught until runtime. And so the way that you combat this situation is that you perform some validation. Now, we're not going to talk about validation until much later in this series, but it's essentially a way to check the type or the value before we actually do the work, and to ensure success. And if we know we can't have success, we would just print out a response to the user. You need to enter a numeric value, and we wouldn't even attempt to get to this line of code. We would just exit out of this code block without even attempting. But that's going to require some code logic. That's going to require some different C# code. Not quite there yet, but we can validate the values before we attempt to do the conversions. Keep that in your mind. Okay? So that's all I wanted to say about data type conversion. Extremely important topic to understand. Okay? So we'll pick it up in the next lesson. We'll see you there. Thank you.